Hey algebra students, it's Mrs. Davidson. I'm going to create a couple of quick videos to reinforce what we have learned over the past couple of days. And this way you can take some notes and be able to work on some practice problems before our test on Monday. So let's start with rational exponents. These are the quick notes that you need for reference, so go ahead and get a piece of paper and a writing utensil and pause the video, get it all set up and ready to go, and then we will fill in these notes together. Alright, so we know that when we are dealing with exponents, we know that we always have like these a to the m type rules. And what that means is our base is there, and now we're doing rational exponents. And rational has the word ratio in it, so we know that our exponent is now a fraction. So we like to say that the numerator of that ratio is the actual exponent, and the denominator of that ratio is actually the index. Now this comes into play because we can use these when we're talking about roots. Remember that if we have a root of 144, what it is asking is what times what number times what number gives you 144. So when we're talking about rational exponents, we can actually write them as radicals. And a radical is just anything that has that symbol. So an example of this is if we were to take the base of a, and now we have it up to the power of 3 over 5. How we would write that as a root is that e is the exponent, so that's the numerator, and that I is the index, which is the denominator. So that index goes right there in that symbol. And if I don't have an index, so if I just have the radical symbol without a number here, that number would be 2. So, coming back to our example, 5 is the index, a is the base, and 3 is the exponent. So underneath the radical we have the base with the exponent. And now we can use this the other way around. We can go backwards in this. So for example, if I just have the square root of a, we know that a is the base. We know the numerator is the exponent, and the exponent attached to that a is a 1. And we know that the index, that would go right here, is the denominator. And because I don't have a number there, that would mean that the denominator, or the index, is a 2. Alright, when you are done with this, go ahead and pause the video, make sense of it, write any notes that you need to clarify, and then we will move on. Next in your notes, I want you to go ahead and get this all set up. You're going to have some trisum up above, and then you're going to have these matching down below. When you are done setting it up, take the time, because your video is already paused, and see if you can answer these. So for these top ones, we're going to make you go from the radicals to the rational exponents, and from the rational exponents to the radicals. And then in the matching, you're just going to draw in arrows for which ones match which. Okay, so here are the answers. And how we went about this was I had 3 as the base. This is the index, so it's the denominator. That's the exponent, so it's the numerator. I know the one with the fraction looks a little scary, but when you put the parentheses around it, you can see that that 1/5 is the base, 8 is the index, 7 is the exponent. Then going backwards, 6 is the base, The exponent is 1. The index is 2. Because it's the 1 and the 2, I don't have to actually write them in. And again, when you put parentheses around the fraction, it makes it a little easier. So my base is the 3/4, my exponent's the 5, and my index is the 2. The matching I'll go ahead and let you fix if you got them wrong. If you did get any of them wrong, go ahead and write an explanation about what you think you did that caused that to not be correct. Okay, so for this next portion, you need to actually just look at this example here and read it all the way through. On your notes, I don't want you to actually take notes of the actual example. You're not copying down anything about the example. But I want you to try and follow along. And as you're following along, you don't have the peers to talk with, but as you're following along, try and understand how they went from maybe like that step to that step. What did they do to go from that step to that step? You're getting the idea. How did they actually move from step to step? Why is this the answer? In the notes that you take, try and answer how the logic of it. What did they use? How did they go there? And put them in words that you can understand. Yes, I have some keys with what's written, but that's not necessarily the way you talk. So as you're taking notes and trying to make sense of this, write it in words that you understand. When you're done exploring this problem and you have the video paused long enough that you can do all that, we'll move to the next and then we'll try one together. Okay, based on that last example, when we have these same bases like this, when we have those same bases, we don't need to do anything. We don't need to write those bases. Now we are going to use that rule that we learned where we had a to the m, a to the n, because what that rule told us to do was to write the base once and add the exponents. So that's what we're going to do. We're going to go ahead and add the exponents. I'm not going to write the bases because my bases are all the same, so I don't need to worry about them anymore. What I only need to solve for is what's happening in the exponents. So when I have the same bases, all I need to worry about is what the exponents are doing. So I'm going to have that x over 4 plus x over 6 equals 3. Well, now I need to just add fractions, so I need the lowest common denominator. I just said b for d. That was funny. The lowest common denominator, which is between 4 and 6, is 12. And now I need to alter my fraction so I make the base, or the denominator, 12. So that means I need to multiply this by 3 to get that to be 12, and I'd have 3x over 12. I'd have to multiply this fraction by 2, so I would have 2x over 12 equals 3. And now I'm going to just add my fractions, and I have 5x over 12 equals 3. Now in the example above, what they did was they multiplied by the reciprocal. Sometimes when I'm panicked, that's too much work, so I'm going to do the inverse operations one step at a time. I'm going to take care of this denominator first, and the opposite of dividing is multiplying by 12. So I am left with 5x equals, let's see, 3 times 12 is 36. And then now I have to divide by 5. And I would have that x equals 36 over 5. Is that pretty? Not so much. Is it a good answer? Yep. Did I do all of the steps right? Let me make sure. 5x, the base is 12. We did that. I have 36 divided by 5. Yep, looks good to me. So that's it for this video. I know it kind of hurts our brain a little bit. Fix what you can. Go back and do what you need. And when you are ready, you can start the next video to see what else you missed.